This is another one of those videos where I write my own math IAs to talk you through what are the things that I feel are important so that you can write an interesting IA and score well on the rubrics. And this one is going to be a very simple topic, so much so that when I started doing it, I felt like it was really going to be too simple, but I always end up getting surprised by that. Okay, no topic is too simple, no topic doesn't have enough math. We can always find something to do, and I hope you'll agree by the end of the video that this was actually interesting. So I like playing Brawl Stars, and there is this particular brawler called Angelo that I don't really like playing with, but his attack is interesting in terms of writing a math IA because the longer you charge it for, the more damage it will do when it hits the enemy. So everybody has a tendency to charge for as long as possible to get the maximum amount of damage. And if you're shooting really fast and getting more shots in, but each one of them only does little damage, then you're playing badly. But that's a question then, now, isn't it? What is the optimal way to play with Angelo? How long should you wait for your shot to charge? Because, of course, doing more damage is better, but also shooting faster is also better. So there should maybe be a balance in between. I don't know. Sometimes in these kinds of situations, there is an optimal point in the middle. So that was the idea, what I wanted to investigate. So the first thing to do is to collect the data, which is why I recorded this video here where I'm just shooting at this robot over and over again with varying amounts of charging time. And I recorded the screen so that I could use that to collect the data, like how much time did I charge, how much damage did I do. But I also want to use this opportunity to show you a trick that I often use for these things where I want to measure how long something is taking on a video. And it's often like really fast things, like the time that I'm charging for here is fractions of a second. So this is a nice little trick that I wanted to talk to you about. So I have the screen recording from the game. I also make a second screen recording that is just from a timer on my phone. I just set a stopwatch running and I'm recording the screen because then I have that image of time being measured in very, very small intervals because that is using fractions of a second, the timer. And then I can use the iMovie app or whatever video app you like to use to just put one on top of the other. That's what I'm showing you here right now. And once you have that video where it's Angelo firing shots and there is a timer on top of that, now you can sort of move it frame by frame almost and get really accurate measurements of how long was I charging for in each of these examples. So naturally, I put all of those numbers into a spreadsheet here. And the start and end times, I decided not to type the decimal separator for the seconds. Okay, so this is 41 seconds, 0.06. This is 43.11. I just did that because it was faster to type and it doesn't matter. I'm scaling by 100 everything, so it's not going to matter. And here is another very simple thing that surprisingly a lot of people ask me about. I am going to put this table in my IA. How do I make it look pretty? Well, that is very, very simple. You please do not insert table from the Google Doc. That's not going to look as good. Just use the Google Sheets where you have your table formatted as you want it. I like putting borders on the cells. I like making the background of the titles a little bit darker, like slightly gray. And then just hold on to everything, copy here, paste over there, okay? That's as simple as that. But I haven't really started writing the IA yet. The table is just here. And actually, I have written some things, but this is not a completed text. It's not how I would submit it to my teacher because I kind of wanted to do some of those things together with you as I'm recording the video because I have some comments on how to write stuff. Okay, so first of all, IAs about games are really super common and I do feel like I am being very uncreative in my examples because this is the second one that I'm doing about a game. But there it is. It's something that I spend a lot of time doing, so it's something that creates a lot of math questions in my mind. Anyway, common thing that people get wrong in math IAs about games is that there is this big temptation of describing the game super well because I like the game, I'm excited about the game, I want my reader to know everything there is to know about it because it's so cool. That please don't do it. You're going to say the bare minimum about the game in order for the reader to understand the math that you're going to do. The reader does not have to understand why you like this game. So this is it. This is my introduction. Brawl Stars is a game in which characters with different attributes try to shoot each other. Angelo is a character whose attack does more damage the longer you charge it for. And now if you play Brawl Stars, you're thinking a bunch of other things, like what about his super? He has that circle of poison. I'm not going to use that in my IA, so I'm not even going to mention that it exists. Oh, but what level was your Angelo? Surely if you level him up some more, he's going to do more damage. Yes, I know, but it doesn't matter because I didn't level him up in the middle of collecting my data for my IA, so it doesn't matter. It's not worth mentioning. A screenshot will be nice. I have this video that I recorded, so I'm going to include a screenshot here. I'm not going to do that now because it would be boring to do while I'm recording the video, but I'll do it later and then I'll show you the final result. After that, I just need to say that I collected the data. I don't have to say anything about the timer that I told you just now. That was between us. That is not relevant for the IA. And then show the table with the numbers. Here's a very simple description of what I just did. And the title for the table. This is really good to have. And one thing that I do think is worth mentioning is that there is a maximum, that you can't be charging for minutes and then do a huge, massive amount of damage because the game doesn't allow that. So that is a sentence that will be relevant. Okay, so a straightforward, simple description. Table should have a title. It's good because we're going to want to talk about, as we can see in table 1 or something like that. So it should have a name. What a lot of tables need, but this one doesn't, is a source, because I collected this data myself. I said so right here. I recorded from my cell phone and I wrote down the numbers. So this is my table. It doesn't need a source. But oftentimes in your IA, your tables are going to be things that you found on the internet. So just right here under the table, right here, would be a good place for a source. I'm just mentioning, but this one doesn't have a source. Okay, this is annoying me a lot. I really don't like it when the tables are broken into 2 pages. But the reason why I'm not going to deal with that now is because there's a lot of things that I haven't done yet. I haven't included the screenshot. I have not double spaced the lines of my text. I haven't thought about what font I'm going to use. So all of these formatting issues, they are important, but look at them in the end. I'm not going to waste time doing that right now. Okay, so right after the table, you can already see this picture, but I mean, you had a spoiler before. You saw this image when I showed you the Google Sheets. That's when it's going to be in the text, but of course I need to give it a title as well, and I need to talk about it, okay? Don't just throw a table of numbers and then throw a picture. You have to talk a little bit to your reader, right? Don't leave him alone. So the text is really the obvious thing, right? The first thing I wanted to do was to learn in what way the damage increases with more charging time, because that's not immediately obvious. I mean, it is obvious now, we are seeing it, it's a linear function, but when we were just looking at numbers or when we were just playing the game, that's not obvious. It might have been something else. So it's good to say that this is what you wanted to do. It's good to say that this is why you plotted it. And then, of course, it looked very linear, so I put a line of best fit through it. You don't have to explain what a line of best fit is because that's in the syllabus. Supposedly, your reader knows it. It's also cool to repeat that in the title of the figure. What are you looking at? What is this figure? It is the damage versus duration and the line of best fit. Now, every time you show a picture, the first thing that you should do after that is to comment on what you are seeing. I'm going to have to comment about the fact that the Pearson's correlation coefficient for this line is really big. But the thing that is showing in my image from Google Sheets is not Pearson's coefficient. It is R squared, which is the coefficient of determination. So in my text down here, I am going to say that just so it doesn't look like I'm confusing one thing for the other. And I'm not going to explain what the coefficient of determination is because I don't plan on using it for anything. But I do want to type R squared equals 0.999 in the correct way, because this thing here on the screen that came from Google Sheets is allowed to type like that. He's allowed to type like a calculator because he is a calculator. I'm not. So anytime that I am going to type something, I'm going to do insert equation, and I am going to type properly. R squared is equal to 0.999. This makes a difference for rubric B. Are you typing things correctly? After the first time that you've inserted equation, you already have this new equation button up here on the top left corner, so it's easier to do. R equals the square root of 0.999, and I really should say what that is equal to, but I don't feel like doing that right now. I'll do it later. And there is an obvious comment to be made here. The reason why it's not perfect, it's not 1, it's 0.999. And the blue points are not all on the red line, even though they are very, very close. It's really good, but it's not perfect. Why is it not perfect? There's an obvious answer to this question, is because data collection is not perfect. I was doing frame by frame, like to the best of my ability. But this needs to be mentioned as a direct reflection on what we're seeing. Okay, so there it is. I have commented about the imprecision of the data collection. And here's the thing, by the way, a lot of people read the rubrics of the Math IA and then try to address everything that is on it, which is a good thing, by the way. You should read the rubric and try to address the things that he says he wants to see. But you should do it in the right way. And there is this thing in the rubric here, this part where he says that one of the ways of showing reflection is to consider some limitation. This is one of the ways, but what I've been seeing is a lot of people thinking that you have to, in the end of your file, include a section called limitations, and then whatever. This is so bad, I can't believe I'm even saying that. First of all, mentioning a limitation is not automatically going to give you a good mark in the reflection rubric. Of course not. And second thing, you don't have to do all of the examples of reflection things that he mentions in the rubric in order to get a good mark in that rubric. Those are examples of things. But most importantly, if you are going to consider limitations, mention them when they are relevant. If the imprecision of my data collection process is a relevant limitation, this is the moment where it's relevant. It's when I am looking at the results from the data that I've collected. So I should mention it here. If I don't say anything here, and then in the end of the file, when the person who is reading already thinks that everything is over, he still needs to read one more section that adds nothing to the thing, saying limitations. Oh, the data collection process is imprecise. This is boring. We don't want to read that in the end. It's boring, and it's also not even organized, which is another good word from the rubric, right? Organization is talking about things when they are relevant, among other things that organization is. Anyway, why are we still talking about this? Let's keep reading what I've already written here. However, there is a delay between firing a shot and being able to start charging the next one. Here, this is about the game. Remember, I told you, don't explain the game too much. Explain only the things that are relevant. And this is going to be relevant because if you play Angelo in Brawl Stars, you can't just fire continuously. You know that. There's a delay, you know? And I want to take that into account in my calculation. So I wasn't particularly trying to be fast when I recorded the video. This is another kind of limitation of the process. I was just shooting. I wasn't trying to shoot as fast as possible. But most of the intervals in the table are around 0.8 seconds. This is something that I can see in my data. And then later I recorded another video that I'm not even going to show you because it's irrelevant. And then I was trying to be as fast as possible, and it doesn't seem to get much smaller than this. Listen, this is me being very loose with the data here. It's kind of like zero point 0.8. It's not a lot smaller than zero point 0.8. I am not really going to measure precisely how much it is, but I'm being honest. I'm writing the things as I did them, and it's still going to be interesting. Let's keep going. Okay, wow, what is this? The graph above shows, this is disorganized. I am going to format my things better later, you'll see. This figure needs a title. Let's put it here, figure 3. And then I'm going to add this later, okay? Name the functions. I am going to include the names of the functions here in the title of the figure, but for now, we are just going to look at the figure and read the description that I put below. The green is the line of best fit, the thing that came from Google Sheets before. It's the same as this red line here, 1442x plus 418. And when I typed it here, you see it's the same things, but this is what I was saying. Google Sheets can type like this. I can't. I can't use calculator notation, so I'm going to put a new equation and type y equals, and then same thing, but typed correctly. See how much better that looks. So in green is the line of best fit obtained from the regression. Since we're interested in optimizing the damage per second, the red function is that damage divided by x plus 0.8, which divides by the time taken to charge, but includes the extra 0.8 seconds of time that is unavoidable between one shot and the next. And then for contrast, I included a blue function, which is without taking that 0.8 into account. It's just the damage divided by the seconds of charging. Look at this. You can't show a result and not comment on it. So let's comment on it. Are you surprised? Are you like shocked by what you're seeing? You should be. There is something a little bit shocking here. So first I write this little paragraph explaining what the red function is doing, why this is the really good one, it's the more realistic one because there is that delay. And then after that, I am going to start talking a lot about the red function because that is the one that I'm studying. It's damage per second. And then I'm going to talk about how it's increasing. I'm going to take its derivative to show that I know what derivative means in terms of increasing functions. But then that takes a while before I can go back and say, oh, look, there was also a blue function, which is like really shocking. So what I am going to try to do now is to make that comment earlier, because I remember I wrote it in the text, but it goes super late. So as somebody who reads a lot of IAs, if I see this picture and then it takes you a whole page to get to mentioning that you're surprised about the shape of that blue curve, I am going to be annoyed at your writing. You have to mention it really soon. You don't have to dwell on it. That comes later. But please let me know that you've noticed it. So here's the sentence that I'm adding. The shape of the g function is really surprising because it is so different from f with just a small change in the denominator. But I will talk about that later. Okay, so now I've put the sentence here. I have calmed the nerves of my reader. He knows that I've seen it. And I can go back to talking about the red function. Here, the conclusion that it gives us is that the optimal strategy would be to charge for as long as possible, which is what people actually tend to do in the game. Which is around 2.5 seconds to get the maximum damage of 4,000 per shot, because this is a constraint of the game. Okay, and now let's talk about math. Okay, this is a math IA. This is happening because f of x is an increasing function, although it increases more slowly over time. You see, I know how to describe functions. This is a skill that I, as a student, have acquired throughout my course, and I want to show in the IA that I have this skill, that I know what is relevant to say about functions when I look at them. So red is increasing, but it's increasing ever more slowly. It is a rational function. See, I'm showing that I know that. Look at the expression of f. It's a linear function over another linear function, so that's a rational function. It is a topic that we study in the syllabus, so it's good to point it out. As a rational function has a horizontal asymptote, which is at y equals 1442. I'm going to type this correctly now. Please do that for all math, even when you think it's just a tiny little bit of math. It was just y equals 1442. It doesn't matter. Type properly. So the horizontal asymptote is at y equals 1442 points per second. It is increasing more slowly over time because it is a concave down function. You see, I am demonstrating that I know my vocabulary about functions here. This is why I am saying things in this way, because I want to score well on the rubric. It is a concave down function, which can be verified by considering its second derivative. Look at all the math that I'm showing that I know with this simple topic of Angelo doing damage. Okay, so now I am going to do derivatives here. I left it for later, do some calculations. So here is the function f of x, and now I am going to do f prime of x and use the quotient rule for that, right? I like leaving a little space between the f and the prime. I think it's more readable. So how does the quotient rule go? You take the denominator and you square it. And then the numerator, you're going to take the derivative of the numerator, which is 1442, and multiply that by the denominator, which was x plus 0.8. And then you're going to subtract that minus numerator, which again is this, times the derivative of the denominator, which is just 1. I'm not sure if I should put, well, times 1 typed like a calculator, definitely not. There is a times symbol here. I'm not sure if I should leave the times 1 there, but I guess it's okay because I'm going to simplify this anyway. So like now, of course, the times 1 is the first thing to go. Now I'm going to distribute this minus to get this parentheses out of here. And I'm going to distribute the 1442, and I'm going to need to learn how much is 1442 times 0.8. 1153.6. Oh, look, the 1442x is canceling out with the other one. So let's get it out of here. And that subtraction is 735.6. That was cute, wasn't it? How the 1442x's canceled out. And it really was helpful because now that I'm going to do the whole thing again for the second derivative, that simplifies my calculations. So anyway, it's quotient rule again, but this time the square of the square is going to give me a power of 4. And let's see here. The derivative of the 735.6 is 0, so that part is not there. Then minus the 735.6 times the derivative of the denominator, which has a 2 now because it's a chain rule. So I am going to multiply that by 2x plus 0.8. And then the chain rule is going to give me a times 1 now. I guess I'm committed to typing times 1s because I did that once and I want to keep the pattern. When I simplify that, naturally I want to do that times 2. So that is 1471.2. But the x plus 0.8 on the top is going to cancel with one of the x plus 0.8 from the bottom, and it's just going to be a power of 3 here. These are results, so now I need to comment on them. The first derivative is always positive. So that's what makes it an increasing function. And by the way, this happens in every rational function. You always have the two sides, and they look very different because they're separated, but it's always either going down and then down again, or up and then up. But the second derivative is negative when x plus 0.8 is positive. That's because it's to the power of 3 there, so if it was negative, then it would cancel with the other negative from the numerator, and it would make it concave up, which, again, if you think about rational functions in general, there is one side that is concave down and another side that is concave up. But in the picture, we are only looking at one of the sides. And the second derivative negative means concave down, right? Yes. Right, moving on. So I've gone back in the file and I've organized a bunch of things. I didn't have a title. So here's the obvious title for this project: Optimal Strategy to Maximize Damage While Playing with Angelo in Brawl Stars. Or maybe damage per second is a more accurate description of what we're doing. The math IA doesn't require a research question. Okay, this is something that a lot of students are confused about. I could, of course, easily turn this into a question like, what is the optimal strategy if I wanted to? But that's clunkier to read. So you don't have to do that. Just speak normally. Much more important than that, I realized I had neglected to write down the aim of the investigation. So that is super important. If you don't do that, you automatically lose something in organization. So the aim of this investigation is to determine the optimal strategy and blah, blah, blah. Notice also that my text is double spaced right now. It looks so much better. I didn't change the font. I just double spaced it. Figure on screenshot now actually has a screenshot. And you see, by doing these things, the table that was previously broken into two pages, like magically is now no longer broken. Table one now takes up the whole of page two. That's fine. And then everything goes on. You see the figures are now in boldface, the names of the figures. Um, I put this number here. The square root of 0.999 is 0.999. It is that big that it doesn't make a difference when you square it. Small little detail, it is obviously not equal to its own square root, right? So put the approximately equal sign here. It is dubious whether you should also put the approximately equal signs here because of course, it's not going to be exactly equal to that, but that is the value that the calculator gave you. So I don't know. This is very, very small detail. So like I said that I would, I have put the names of the functions here. I should also say the colors. This one is the green. This one is the red and this one is the blue. So now the title of figure 3 says everything that you need to know about figure 3. And I am also referring to it in the text. Okay, I had forgotten to do that before, but that is why we name our figures and our tables. Before it says here, the graph above shows in green. That is not the best way of writing about things like the graph above. Why is it above? It could be below, it could be in a different page. Call him by his name. This is figure 3. Okay, so everything else, I don't think I've changed anything. So this is where we had stopped. We discussed the derivatives. We talked about the damage per second, including the 0.8 second delay. It's increasing, it's concave down. The optimal strategy is to hold for as long as possible and then fire a big shot. Okay, now let's go back to talking about the blue function, which is actually going to be the more interesting part of this IA. However, the truly surprising thing for me in the graph, no, what graph? In figure 3, because this is how we talk about things, was the blue function g of x. Of course, I expected that not using the 0.8 would make some difference, right? We all did. But I wasn't expecting that the conclusion would be totally opposite. Like one of them is increasing and the other one's decreasing. What's happening? The function g of x is also a rational function. The horizontal asymptote is also at 1442 points per second, but this one is decreasing, making it so that the optimal strategy, if there was no delay, would be to always charge for as little as possible. This is the exact opposite conclusion, and this is so shocking. So the first thing I'm going to do here is to do the derivatives of g. Of course, we have to go through the same process to understand what's happening to the other one. The conclusions are reversed. The derivative is negative, meaning that the function is decreasing. The second derivative is positive, meaning that the function is concave up. Well, I should say that the second derivative is positive for positive values of x, because that's the part of the picture that we are looking at. I mean, the negative x's are not going to matter for Angelo, but it matters for my understanding of math. Now is a crucial moment here. The number one question that I get about IAs, undoubtedly, the number one question is, how do I show personal engagement? And I hate this question because it's a bad question. It's not about how do I show it. It's like There is nothing that you can do in writing to pretend that you were personally engaged. Like, you're asking me how to pretend. That is the wrong question. What you should be doing is actually being engaged. That's number one. And number two is write truthfully about what you're going through as you're doing the investigation. That's the serious answer to how do I show personal engagement. It has two steps. One, be engaged. Two, write truthfully, because a lot of students try to treat the math IA as a list of checkboxes that you check, and in the end, I mean, of course, you can do that, but there is no personal engagement in that, and there is no checkbox that is going to tell you how to be engaged at the specific moment in your IA. That's the beauty of it. The engagement is yours. It's nobody else's. So this is not a checkbox. This is just a general way of being curious about stuff, which in this particular moment, in this particular example, is manifesting itself as, listen, with a delay of zero point 0.8, the function is increasing. With a delay of 0, the function is decreasing. I wonder when that changed. I wonder what is the critical delay point, which is going to be a number between 0 and 0.8, that makes that switch. And I wonder how that switch looks in a function, because it like turns upside down suddenly. How does that look? So this questioning, this wondering about things, this is not a checkbox. This is a way of feeling about math. This is personal engagement. So step one is the feeling. Here it is. We were just talking about it. Step two is how do you write about it? So naturally, I started wondering, if it's decreasing for 0 delay and increasing for 0.8 delay, there must be an amount of delay where it changes from decreasing to increasing. By testing many different values, I saw that for a delay of around 0.29 seconds is where it changes, becoming a horizontal line instead of a rational function. And in terms of writing in the IA, this I think is enough writing, because you trial and error, you tested different values. But I actually do want to show you how I did this, because I just think it's fun. So here we are. This is GeoGebra Classic, which is where I do most of my graphs. I am typing the function now. I've just typed it. I haven't clicked enter yet. And notice that instead of a number, I have a variable k there. Now, this is something that's very neat that GeoGebra does. I have never told him what k is. So when I click enter, he's going to realize by himself that k needs to be a value, a parameter that is going to change. And he makes a slide bar for us to adjust the value of k. Now I'm going to hold down the shift key here and push down my axis so that it becomes the kind of scale that I need. And I can also go in the settings, because the settings for the slider have something that I want to change as well. I don't want negative values. This is a time delay. 5 seconds is way too much. The maximum can be 1. And the increment, I want the increment really small. I think that the default increment that he uses is 1, so that is like way too big. I want 0.01, like a really small increment. So what is going to happen now? You see, look what this function is gradually doing as you gradually change the delay. It doesn't change much when the parameter changes just a little bit. This is not surprising. This is what you expect. A small change has a small effect, but you know that at some point it's going to flip upside down. So let's move really slowly to try to see how that happens. Look, it's getting, the two sides are getting really closer to each other. You see, whoa, what is that? And now it's changed. And this is how they change. This is absolutely beautiful. And anyway, the value where it seems to be changing is 0.29, which is what I wrote in my thing. So by testing many different values, I saw that for a delay of around 0.29, that's an approximate value, of course, it was the intervals in which the slider was changing. is where it changes, becoming a horizontal line instead of a rational function. And I really think that the exclamation mark is called for because this is exciting. But I want to try to deduce mathematically what is this value. Okay, trial and error is fine, but when you can do more, also do more. Consider the function hk with a k. And this is a good thing in terms of notation to show that you are comfortable doing. The k here in the denominator is the same as we just typed in GeoGebra. I know you're comfortable with that. But this k here with a subscript k in the name of the function hk, not everybody is comfortable with that. This is standard mathematical notation for family of function. F was one function, G was one function, but H is not one function. I want H to be a family of functions because I want this freedom to change the parameter, the amount of delay. So a very common way in terms of notation to write that down is to put it as a subscript in the name of the function. Oh, the delay is k seconds. This k should be an equation. In order for this to be a horizontal line constant function, say it will be the value p, then this is what happens. P is the constant value of the function. And then what am I doing? I'm just multiplying both sides by x plus k. You can write this down if you want, like the step-by-step, like here, multiplying both sides by, I'm not going to do that. You can do it if you want. But here's an interesting thing that I want to tell you happened between the second and the third line here. Actually, between the second and the third and fourth lines. Because the second line has three letters, three separate letters. There's a P, there's a K, there's an X. This is so useful in so many situations. This is not one equation in three variables. This is an identity in X. We are not talking about find the value of x for which that fraction is equal to p. We are talking about that fraction is a function which is the constant function equal to p. So for any value of x, that first line is an equality, and so is the second line because they are the same, just multiply by x plus k. And in order for the second line to be true for all values of x, then you need to equate the coefficients individually. Like the p that is multiplying the x on the left side needs to be equal to the 1442 that's multiplying the x on the right side, because the pk and the 418, they don't have x. So they're not going to change as the value of x changes. But the 1442x and the px are going to change, and they have to change in the same way if the identity is to be valid for all values of x, which is what we want. So actually what we're seeing here is that the third and the fourth line are both direct consequences of the second line. I don't think that the way this is typed here fully represents that, because it looks like they're third and fourth line in order. The proper way to write this would be with a thingy on the side, like a system of equations. Unfortunately, the equation editor in Google Docs does not do that. There are a bunch of different ways in which you can properly type math. I know of different ways to get the effect that I want, but there is one that I particularly want to show you today. The Google Docs equation editor doesn't do the thing that we want. You know who does do that? ChatGPT. So I'm just going to ask her to do just that. Please don't try to do math with ChatGPT. She doesn't know anything, but she does know how to type. So you have to tell her exactly what you want. If you ask her what is 2 plus 2, she'll get it wrong. But I'm asking her to format a system of equations for me. The first one is P is this number. The second one is PK equals that number. I think she's able to do that. So that's not really what I wanted, ChatGPT. So she didn't put the bracket. I'm asking her specifically for the bracket now. Let's see if she does it. That is now an image that I am going to cut from my screen and paste it into my file. So yeah, from the second one of those, you divide both sides by 1442 and you get k equals this fraction. And here's that little detail again, k equals this fraction, which is approximately equal to this number. Again, it's questionable whether this should already have been an approximately equals to, because both of those numbers came from a regression line that came from data that was imprecisely collected. But I think there's a limit to how rigorous we want to be with that. So I'm just going to leave it like that. And I did say I chose to put a lot of significant figures because this just rounds up to 0.29 so neatly that it was going to look as if I was just saying the same number again. I think it would look like that. So here's a sentence about that, about how close they really are. Here's that comment that I was making before, that the equation by itself gave the next two lines as separate conclusions. And I'm just going to more or less type what I told you about it. Here it is. And in case you're a high level student, this kind of thing is so common in complex numbers problems, where you want like one complex number to be the same as another complex number, and then you equate the real parts and the imaginary parts because they don't interfere with each other. So one equation in complex numbers is the same as two equations in real numbers. And that is the same kind of thing as what is just happening here, even though this IA has absolutely nothing to do with complex numbers. And now here's a final reflection paragraph. Remember how my zero point 0.8 measurement for the delay was not very precise at all? But like 0.29 is like 0.3. Like if it wasn't 0.8 and you told me it was 0.7 or 0.6, okay, I can believe you. But 0.3, no, it wasn't 0.3. That is too far away. So the thing is, between the decreasing type of behavior that the blue function had and the increasing type of behavior that the red function had, I know that it's the red that is reflecting reality. So that is the one that tells me what the strategy is. You should hold on for longer. However, that is not always very realistic in the game. You don't always have an enemy close to you that you want to shoot at. You're not shooting all the time. It's very common to spend some time not shooting, like running away from other people and doing other things. Then at the moment that you first see an enemy, you shouldn't count the delay because there is no delay. The delay has already passed. You have been not shooting for a lot longer than 0.8 seconds. The first shot that you start charging is going to start charging when you push the button. There's not going to be a delay. So starting from the second shot, if you're going to fire multiple shots at the same enemy, then the delay does count. So for these reasons, I would say that the optimal strategy is to first fire one shot very quickly, and after that, charge for almost the complete time that is allowed, because that is optimal. Don't exactly try to hold on for the maximum amount, because you won't be so precise and you'll probably waste some time after you reach that limit that it doesn't do more damage than this. So also if your enemy's current energy is less than 4,000, then there's no point charging more. But anyway, that is the end. That is the end of the IA. This is 7 pages. It is a little less than the recommended page count of between 12 and 20. Students get very nervous about this. They ask me, what is the word count for a Math IA? Math IA doesn't have a word count. Math IA doesn't have a page count. It is a suggestion. Between 12 and 20 is usually okay. It doesn't mean that it can't be outside of those numbers. Usually what happens is that students will go over a little bit, like 21 pages can be okay, 22 can be okay. 7 is a little more rare, but honestly, I prefer that. It takes me less time to read. All of the information is here. Don't try to stuff it with irrelevant things. What I should do now instead is go look at the rubrics and see how I'm scoring with the 7 pages that I have right now. Criteria A, presentation. The words to look for are coherence, organization, and conciseness. Coherent exploration is logically developed, easy to follow, and meets its aim. Easy to follow is like if you read it, give it to a friend to read. Can he understand what you're saying? If he can't, that's incoherent. and meets its aim. Did I meet my aim? My stated aim was to determine the optimal strategy. My concluding paragraph says what the strategy is, so yes, I did that. This refers to the overall structure or framework, including introduction, body, conclusion, and how well the different parts link to each other. I think there is a flow in this text. I was telling a story just like I was in the video, so that's good. It's coherent. A well-organized exploration includes an introduction, describes the aim, and has a conclusion. This is something that students often confuse for section titles. You will notice that I do not have any section titles. It's not that I'm against you having them, I just didn't feel like doing it, which is often my style. But this is the introduction, this is the aim, and the conclusion is the last paragraph. So I guess I'm good in that. Relevant graphs, tables, and diagrams should accompany the work in the appropriate place. Yes, I've done that. And not be attached as appendices to the document. Appendices should be used to include information on large data sets, additional graphs, diagrams, and tables. I don't have any of that. My only table is like just one page, so it is attached in the proper place that it should be. So I am well organized. I am definitely concise. I am only 7 pages short. Does not show irrelevant or unnecessary repetitive calculations, graph, or descriptions. This is fine. The use of technology is not required, but encouraged where appropriate. Sure. This is about, you know what this is about? I did a lot more. This is not just a simple correlation IA. It ended up being about rational functions and derivatives. But when I started doing it, I did think that it would be a correlation IA. This is the thing that I was thinking that was going to be there. And I didn't talk about it at all. I just let Google Sheets do it. And a lot of people, especially in correlation IAs, they think that they need to go copy some text from someplace else. There's a weird formula with summation signs for how to calculate Pearson's coefficient. That's not even ever mentioned in the course. So please don't do that, because that is not concise, and because the use of technology is encouraged where appropriate. You should be doing these things in the calculator and discussing their results rather than doing things by hand unnecessarily. The use of analytic approaches rather than technological does not necessarily mean lack of conciseness. And what this means is when I was doing derivatives, because even though you are not allowed computer algebra systems in your exams, you do have to know how to do derivatives by hand. For your IA is different. So we know that these things exist. There's Maple, there's Wolfram, there Photomath. There are technology solutions that do derivatives for you, but I chose to do the quotient rule by hand here because it was small enough. And this is not lack of conciseness. This will not be penalized. So I am scoring a 4 in criteria A here. Mathematical communication, the keywords are relevant, appropriate, and consistent. So mathematical language, notation, symbols, terminology. I mentioned these things throughout the video. The notation for hk of x, for example. The terminology. This function is increasing more slowly because it is concave down. So I'm using these things. Calculator and computer notation is acceptable only if it is software generated. Remember, this is in the picture here. Like I mentioned, this is okay. Everywhere else, it's not okay. Otherwise, it is expected that students use appropriate mathematical notation. Define key terms and variables where required. And I wasn't really paying attention to that, but I think I did it because like f and g are defined here. The red function is f is this expression, g is this expression. The age function is defined here as well. And when I introduced this new p, it was like, say it will be the value p. I think this is good enough in terms of introducing notation. Multiple forms of mathematical representation, formulas, diagrams, tables, charts, graphs. I have all of that. Again, you don't have to have every single thing. These are examples, and you're supposed to use the ones that are relevant to your work. I don't even know what he means by model. Anyway, deductive methods set out proofs logically where appropriate. Where appropriate, I mean, it doesn't have to be, but I think there is a little bit of that in here in this part. So, yes, I think I did achieve level 4 in mathematical communication criterion B. Criterion C, I don't think I did. I think that in order to reach the outstanding personal engagement, it would have had to be numerous instances, and the impression that I have developed through my approach a complete understanding of the context. In order to get this, I would need to go further. I would need to generalize to rational functions. Listen, so this is a common thing for students to wonder about rational functions. Sometimes they are like this, sometimes they are like this. So how do I know when's going to be one and when's going to be the other? This IA provided me an opportunity to explore that question and find an answer that would benefit my thorough understanding. I did not do that, so I am not giving myself 3 points here. I think I am giving two, though. Significant personal engagement, authentic personal engagement on a few occasions, and it is evident that these drive the exploration forward. Sure, I'm all the time saying, hey, I wonder about this, so I'm going to do that to figure it out. This is personal engagement. So I think we should read this paragraph. The personal engagement assesses the extent to which the student engages with the topic by exploring the mathematics. It is not a measure of effort. Listen, I know that nobody here is thinking that it's a measure of effort. It is not a measure of how much you like your context. It is not a measure of how much I enjoy playing Brawl Stars. That's not what's going to give me personal engagement. And this is why I almost don't talk about Brawl Stars at all in the file. It is engagement with the mathematics, exploring the mathematics. It may be recognized in different ways. This includes thinking independently or creatively, presenting mathematical ideas in their own way, exploring different perspectives, making predictions, testing. It is a subjective overall thing. It is not a checkbox that you're going to check at some point in your file. So I'm giving myself a 2 for this one. Reflection. Limited, meaningful, substantial evidence of critical reflection. I think I'm going to go with 2 as well, but let's see what this means. Simply describing results represents limited reflection. That's the bare minimum. Whenever you see a result, you describe it. Meaningful reflection. Some examples are, some ways are, linking to the aims of the exploration. I think this one is stupid, by the way. If you're not linking everything to the aim, then what are you even doing? Commenting on what they have learned is one that some IAs, particularly this one, provides a lot of opportunity for, because I did learn things about rational functions, considering some limitation like people stress so much about, or comparing different mathematical approaches. I don't like this list. I don't think it's an exhaustive list. I don't have a better list to give you. I'm sorry. I think reflection is also subjective and overall. Just be curious about what you're seeing. Be surprised about the surprising things. Comment your thoughts. Now, the reason why I'm not going to give myself a 3, and I almost never give 3 to any of my students, critical reflection is reflection that is crucial, deciding, or deeply insightful. This is beautiful wording, and it's also very, very strong. It will often develop the exploration by addressing the mathematical results and their impact on the student's understanding of the topic. You see, I could have done that. I just chose not to because it would be too much work. Some ways of showing critical reflection are considering what next, which is also another thing that a lot of students treat as a checkbox. They always do what next paragraphs in the end of their file, as if that alone is going to take their 0 personal engagement into a 3. This does not help. Discussing implications of results, strengths and weaknesses, which is also another one that is easy to latch onto but doesn't really do anything on its own. And not only does the 3 have to be critical, but it also needs to be substantial evidence of critical reflection present throughout the exploration. Obviously, this is always true. So I'm not giving myself this point. For the use of mathematics, if I'm an SL student, I am definitely using something that is commensurate with the course, which is rational functions and line of best fit as well. The differences here are going to be how good my understanding is. Is it limited, some, good, or thorough? There's also a thing about being correct, like partially correct, mostly correct, and correct. But to be honest, I rarely see wrong math in IAs. Like people are doing this at home with time on their hands. The math is usually correct. The decisive thing is the amount of knowledge. And let's see, what knowledge have I demonstrated? I like this sentence a lot because this demonstrates some deep knowledge about functions being equal to each other as functions. I've also discussed like the implications of positive and negative, first derivative, second derivative. I'm demonstrating that I know those things. I wouldn't call it thorough though. Thorough is such a strong word, so I'm giving myself a 5. This is a 17 out of 20 if I am an SL student. If I am an HL student, doing the exact same IA, I don't have the full rubric in this file, which is unfortunate. But I do know that level 5 says rigor or sophistication. 6 says rigor and sophistication. I don't think I've used either rigor or sophistication here, so I would probably give myself a 4. So that would be a 16 out of 20 in HL, which is also very good.